if that's so, let me get back to the lecture material a little bit. Okay. So what I'd like to do today is, last class we started talking about a little bit about some of the issues of dealing with large data. My hope for today is we will spend some time discussing, the MapReduce paradigm of working with large data sets, which is, an important thing. And then hopefully we will have some time to, I will hope to have a lecture, end the lecture talking about some ethical issues in data science and maybe crowdsourcing if we get to the time for it. So, it's interesting. When I first started teaching this class, the thing that all the students wanted to learn desperately was Hadoop. Okay, this was, I think now people more desperately seem to want to learn about, deep TensorFlow or something like that. But Hadoop is a kind of open source type implementation of Google's MapReduce paradigm for distributed computing. And what's good is it offers a way of, again, we have this problem that when we have really large data sets, we need lots of machines to program lots of different machines. You need to have some kind of system support to make it easy or convenient. You need some kind of system support to communicate with these machines while having a relatively simple programming model. And the system support has to deal with, among other things, fault tolerance. As we saw, when we have a large enough group of objects and running for a long enough period of time, somebody's going to die. And you got to figure out how do you do this in a way that it doesn't ruin the entire computation. So these are the kind of things that a MapReduce, Hadoop was designed to help fix. Now, what is a typical big data problem? So I'm imagining a world where you've got if you have a huge number, a lot of, let's say, text data records. Okay, maybe you're dealing with a text corpus of all of Wikipedia or all of the web. That's an even better thing. If you go onto Amazon, you can get access to the Web Common Crawl. This is all the entire web. Suppose you wanted to count how many times each word occurs on the web. How many times does defenestrate occur? Okay, or any other rare word, or all words. What would be a way to do this? Well, basically in a problem like that, which would be analogous to like word counting, the files that you're working on are separate things. You'd like to put all the split the files up among machines. On each machine, you would like to scan through all the data files, all the text files on that machine. You'd like to extract something from the text file, maybe in the word counting example. That might be, for every word that's appeared in these documents, a count of how many times did it appear. Then you want to take this data and aggregate it from all the machines that have had files that you were scanning it on. Okay, so there's a question then of aggregating the intermediate things. Count up how many times did defenestrate occur on each machine, and that's kind of the output. So a lot of problems kind of reduce to making sweeps over large data sets. Let's say you wanted to do k-means clustering. Remember k-means clustering? We had a bunch of points. What was the basic iteration in k-means clustering? We arbitrarily picked certain cluster centers at the beginning. The first sweep is we would like to be able to go and for every point in the data, figure out which center is it closest to. So you could imagine a world where you have many files of points on many, many different machines. If you sent each machine the the 10 cluster centers we have now are, on each machine you could take each record and identify which center is closest to it. You then may want to throw the points around to other machines so that all the points that have the same nearest neighbor, nearest cluster center are on the same machine. Or maybe you want to send the median, the centroid of all the points for each that are nearest to each cluster on each machine. And then you want to aggregate this information. Okay, so you accumulate what were the centroids of the points and the count of the points closest to me, okay, for every cluster center. Once you have this, maybe you're now going to want to repeat. Does everybody see that kind of k-means clustering also has this property? Okay, if the points sit on machines, okay, you want to compute what the cluster centers are in rounds of sweeping through all the points. Okay, any questions about that? So this is typically what happens. If you have multiple machines, you do divide and conquer. You want to divide the work among workers and then kind of combine the results. If you're going to do this with a computer system, there become several challenges that you need the software to kind of deal with. One is, how do you assign the work units to workers? Suppose, let's say that all the log files were on one machine and you've got a bunch of different servers. Okay, how do you assign the amount, which files to which machines? Ideally, you want that to be roughly balanced, okay? Or else the whole job will take longer, okay? If you have more work units, more files than there are workers, when do you assign a second piece of work to a worker? Okay, you ideally will maintain a queue of work. And whenever anybody is done, they say, give me more, okay? How do you know when all the workers are finished? Something's got to be coordinating all of these workers. And there's got to be kind of some central head node that is going to coordinate the workers. And they're going to have to know enough about what was assigned to what worker, that if a worker dies, okay, their work can be done by somebody else. Okay, any questions about that? This is kind of the thing you want in a MapReduce system. Okay, we want to be able to do these kind of things. One of the ideas that was important in kind of MapReduce was that if you're dealing with big files are usually not in RAM. Big files are usually sitting on a disk someplace. And the cost of bringing them into RAM is what is expensive, okay? You don't want to jump around a file and read part of it and then go to another part, because the seek time on disks is expensive. What you'd like to be able to do is to process each file sequentially and sweep through it, okay? So that becomes kind of the more efficient way of doing it. Any questions? Okay, so when you use Hadoop, there's kind of two different parts of Hadoop. One that many of you have heard of, the acronym HDFS. That stands for Hadoop Distributed File System. This is a, basically distributed file system that is maintained on a bunch of different machines. So typically the way I like to think of what HDFS is, to a certain extent, is like a giant hash table. Typically, if you have a bunch of different machines that you're using, each of these have a certain amount of RAM, the Hadoop file system essentially combines the RAM of these machines, okay, and treats it like it's a giant hash table. And then uses the network for these machines to communicate with each other. Okay, we want to minimize communication. Okay, but we want to do it in a way that, again, it's fault tolerant. The Hadoop file system makes 3 copies of everything, so that if a copies everything on 3 different machines. So if this machine dies, there's 2 other machines that have all of its data. Okay. So that's the HDFS. The other thing that they have is the runtime system, which is called MapReduce. Okay, that provides the abstraction and the scheduling of how the jobs are going to be scheduled. Any questions about that? In MapReduce programming, the basic idea is that there are 2 different kinds of operations. Mapping takes a key and a value and kind of assigns it a new key and maybe some processed value data. Okay, so maybe you can imagine, let's say a key is a word, and maybe there's some other data associated with a word. Mapping is basically something that hashes the key to a hash code, and associated with that hash code carries some data that may or may not be the same as the data that that you already had, that you gave as input. Maybe you massage it a little bit and do it. So mapping basically takes the keys and throws them into a bucket based on the hash of the key. Reduce is an operation that takes the bucket of values that had been hashed to the same key and does some computation on it. Okay, if it was the word count example, if, let's say, we took every word and the number of times that word occurred in a particular document, okay, the mapping is going to assign all of the, who's going to hash all the instances of that word to the same hash code. And it's going to carry along with it to that record, is going to carry along with it that count. This is going to be building in some sense on a machine somewhere in this distributed hash function table. It's going to be building a log file of all the things that got mapped to it, to that key. When you call reduce, it takes that log file associated with the key, does some computation like adding the counts together, and returns basically just the tuple of, for that hash code, what is the total. Any questions about that? So the way to think about it, you have all these different processors. When they have a record, they're going to map it, mapping it. Okay, if the key is going to be A, there's going to be an A bucket, and all the A records get hashed to the same place. All the B records get hashed to the same place. Okay, all the C records get hashed to the same place. Okay. Once you have this, then if you want to do a process like aggregate the counts, it's just a question of going through the resulting map file. Any questions about that?
What is A, B, and C? Do they represent different machines, or are they just like random hash codes?
No, the way I think about it is these are hash codes, okay? And this is the associated data here, okay? So, so again, if we think about it as a word example, here you've got a lot of data coming in. Each one of this was done on separate, in separate files on different mappers. The key of the that's being, when you map it, there is a key and there is an associated data item. Mapping using the Hadoop file system, We can view that as a distributed hash table. All the records that have the key A are getting thrown into the same place in this distributed hash table, where there is a file that's serving as a bucket that's storing those keys. Once we have finished mapping all of these things, then the second phase of the computation is to run a reduce job that for every bucket does something with the records that were mapped to it in word count and adds that together. Okay? Any questions?
So the buckets do, as the programmer using Hadoop, do we care which piece of data is in which bucket?
You don't care. Okay, you do care which data is in which bucket because the buckets are used for grouping. Let's look at this as maybe a code-like example of what the program might look like. A map program would say, let's just think that there is a emit command, okay, that will basically take the pair here. Remember here, pair is, okay, so let's say we wanted to do word counting. You have a bunch of files. You have a bunch of possibly of different machines you're going to be using. Each machine is going to have a map job running on it over whatever files it is given. And what it's going to do is, for every word in the text, it's going to emit a pair, which is the word and the count of 1. So for if the word defenestrate appears in this text, it's going to output a key defenestrate, comma 1. The 1 is supposed to represent the count. Now, when we hash it, there's going to be a bucket where all the occurrences of the word defenestrate are going to be thrown into the same bucket. And then in order to get the count, there is a reduce job where you say that basically for any term, okay, start this go for the bucket associated with any term. This is the term, this is the bucket associated with it. Go through the values, and for each value, add that to the sum. And finally, output the term, which would be defenestrate, and what is the number of times it occurred. Does that answer your question?
So as the programmer, you choose the buckets?
As a programmer, you don't choose the buckets. That's what's great. What you choose is what is the thing you're grouping by. And in a word count program, what you're doing is you're grouping it by the word, the different vocabulary word. The word count program says for every given a large amount of text, for every word in the vocabulary, how many times did it occur? In this kind of a program, you're coming up with a, a bucket. You're saying, I want to create a bucket for every possible distinct vocabulary word. And so for every distinct vocabulary word, I'm saying, put it in the hash, add a record in that distributed hash table under that word with a count of 1. And then the reduce operation says, for all buckets in the hash table, okay, go and sum up all the entries that are in that bucket. So you are not, what's interesting, you, the programmer, are not deciding what buckets belong on what machine, okay? You're trusting Hadoop to maintain this distributed hash table. And presumably this bucket is going to exist on some machine after the mapping, okay? Does that answer your question?
Yeah.
Okay, good. So again, this is just a essentially another way of essentially a writing of the same thing. So what is kind of the vision here? Here we have a world where we had 3 different, let's say, machines. starting out with 3 different documents, okay, that we are mapping to 2 different, that we are going to map, okay? What are we doing? We go through the, each document, and for every word, we map a, we generate an emit command that for that word in the count. If this emit command is basically going to hash those words. If we have here we have our giant distributed hash table. When this machine, the second machine outputs a the, and the first machine outputs a the, they are getting hashed to the same place in the hash table space. So both of these are going here, okay? And actually, this one is going twice, as you noticed. There were 2 emits here and 1 emit there. Then once we have accumulated this hash table, we're going to use a certain number of machines to do the reduction, to do the actual counting on these files. Here we only have 2 such machines. We logically divide the hash table space into 2 equal chunks. This machine is going to go through all the buckets that were on this half of the address space. This will go through all the chunks that were on that half of the address space and basically add up these things. And now we have a record for every word. What is the total amount of times that it occurred? This is probably small enough data. We want to ultimately send this to the master node, and that's what the output is. Any question about that? So that is the basic idea of these kind of MapReduce programming. There's a couple of other primitives that you need to know, or that come up when you're actually complete the program, but that's basically the idea. One is how many chunks of, how many reducers do you want? How many chunks do you want to carve the ultimate, hash table into logically, so that all of that these parts of the bucket go to the same reducer? There is a second command that to try to reduce the amount of network traffic called combine, that might, instead of just sort of immediately emitting a message every time the word the occurs, it might say, let's go through a file. Before we send out the counts, let's run a local reducer to maybe add these guys up, so we don't have to send as many messages around. So if we had done a combiner, we would have, before emitting to the to the other machines each word, we go and we do a local emit like we did before, but we do a local combine before we send it out. That would basically aggregate the 2 thes instead of sending separate messages. Any questions about that? Okay, this is the basic idea of MapReduce kind of programming. And if you have a large number of things you have to go through, okay, and you have a lot of machines, this is a good way to do it. Any questions? I think at one point I mentioned we once had this company, General Sentiment, that would analyze the Twitter feed every night. And we were wanting to try to do things like count how much was every entity mentioned, how much were they mentioning Toyota or Trump or anything else. That was essentially, that kind of social media analysis was essentially a MapReduce kind of essentially a word count computation. Okay, of course, exactly what we wanted to count and stuff like that was what made it interesting. But basically, we rented 50 machines a night, and we partitioned the Twitter feed among the machines, went through that. We had a distributed table of the counts. We then ran reducers and stuck the thing in the database. Any questions about that? Now, many of them, now these days, there are sometimes higher level distributed databases you guys may use. And these distributed databases probably have something like Hadoop underneath it, okay? Maybe there's less programming of raw Hadoop now than there used to be, okay? But the reason is because there's sort of these higher level databases that, that people use as distributed databases instead. Any questions? But underlying those distributed databases is typically some kind of a MapReduce system. Any questions? So again, there was the distributed, the runtime for MapReduce does things like, for a new job, which processor do you assign it to? Okay, you do it makes sure that it's done all the mapping to files before it starts reducing them. Okay, and it deals with if a project has, if a file machine dies, which files need to be rerun. Okay, any questions about that? Okay, and like I say, what you call it, the Hadoop file system basically takes a bunch of machines and puts them into one big hash table. It uses the RAM to hold the, to do the lively connections of things. But ultimately, once the reduced files get big enough, they append them to files. Appending files is faster than writing in the middle of a file or doing something complicated like that. Okay, so the whole thing works surprisingly well. Any questions? Okay, any questions about that? And finally, if you want to play around with these things, again, one of the things that is good about these MapReduce jobs is they demand you need a lot of machines in order to get a good parallelization, but you may not need them for that much of the day. You may only want to run this job once a year or something like that. With these cloud computing services, you can rent a large number of machines by the hour, okay? Run a big job on them, and then give them back to Amazon or Microsoft or Google, okay? Any questions about that? Any questions about MapReduce programming? Obviously, this is a fast thing. If you want to learn more about that, Professor Schwartz teaches a big data class, okay? That would be a good place to learn more about these kinds of things. Any questions? Once, twice, solved. Okay, the last thing I would like to talk about is sort of the ethical issues in AI. Okay, that this is I think that engineers tend to be squeamish about soft kinds of things, and ethics and trying, are we supposed to do right, do wrong? This is kind of a soft thing, but it has become a, the advent of machine learning models, big machine learning models, and big data analyses have kind of led to a bunch of different kind of societal issues that people should be sensitized to. And so I want to use the rest of the semester to talk about this. So what do people mean when they talk about ethics? Ethics is kind of defined, at least in this definition, as kind of moral principles that govern a person's behavior or the conducting of an activity. It's not about whether something is legal or illegal, although hopefully the law reflects what's good and bad. Okay, it's more of ethics is more about what's right or what's not right. Okay, and so typically, you want to try to have some kind of, there's principles that you want to have. Often these principles are in tension. Okay, the company should want to be able to do the best it can with data that it owns. That seems like a reasonable principle. On the other hand, people have some, level of, right to privacy and to know what's being done with their data, and that's also a different thing. So with ethics, it's kind of about resolving different stakeholders' opinions, different principles, things like that. And, there is, I would say over the last 3 to 4 years, there has emerged a lot of ethical concerns about what people do with data. And this has become probably an increasing issue rather than one that's been going away. And when you listen to what people worry about when they talk about data, about what do they dislike about Google owning all their data or Facebook owning all their data, I think that there are kind of like 4 different kinds of concerns the public has. And this, by the way, I'd like to be a discussion. I can sit here and preach for the next 25 minutes. But if there's some things people want to talk about, I think this is a good thing. But generally speaking, I think that there's 4 things that the public gets concerned about when they think about machine learning and data science and all these kind of things. One thing they are worried about is AI going to eat their lunch? Okay. Are machines going to take jobs from people? The world, it is good when everybody, is employed in a respectable and dignified job and earns their keep. Okay. A lot of people are concerned that machine learning will take things away, jobs away. That is one concern people have. A second concern that people seem to have is about loss of privacy. Okay, they think that it is wrong that that Google or Facebook may know more about me than I want them to know. And this takes all kinds of different forms. One form that that I remember being kind of interesting is that one of these models, maybe from, I don't know if it was from Google or it was Facebook, noticed that if somebody was looking at ads showing that maybe they were trying to buy diapers or look up obstetricians or pregnancy tests or things like this, that Google would figure out whether this person is pregnant, maybe before they tell people that they want to know, anyone else to know about it. And there's cases where, people have started to see ads come up, okay, because seemingly the model has inferred something that's very, very private about me, about the person. I remember once when I was using Google, my mother lives in Florida. She was ill, and so I was changing email with my brothers and things like this, and making plane tickets to go visit her, to come down to, and I started seeing ads on Google for funeral homes in Florida. The model had, the models had learned somehow that I had a relative who was ill, okay, and that that maybe was old and ill, okay. And this was at the very least kind of creepy. It's a question of whether these machines are getting too much information about me and doing this. My mother came out of it fine, by the way, so everyone's happy. Okay, but I thought that was interesting. A third class of concerns that comes up about ethics in data science has to do with biases. Okay, that there are certainly biases in society with respect to race, with respect to gender, with respect to a lot of different things. And it is surprising how often very subtle biases, that in any kind of training data, there are things that machines can learn from the data that are maybe even, illegal to act on. It may decide that one racial group is better to hire from than another. Okay, it's surprising what kinds of subtle biases there are in data that you get. Okay, and the models learn these biases, and the fact that these these systems get, make increasingly important decisions. Okay, is something people get concerned with. And the final thing that when it comes to AI and machine learning that I think people get afraid of is, our computers going to take over the world? Okay, everybody is afraid of what do you call it? Oh goodness, what I'm forgetting. What is the word for when the computers sort of exceed what people can do? Has anyone ever?
You mean the AI singularity?
The singularity. That's exactly right. Are we coming up with a world where the computers are going to take over and start doing things for themselves, and eventually we're just going to be an inconvenience to them? Okay, these are the kind of things I think people worry about when it comes to machine learning models. Some of them are more grounded in what I would say legitimacy than other things, but all of them are things people worry about, and that we as responsible engineers should try to deal with something, should be aware of that. Any questions about it? Again, there's a lot of books written on these kind of ethical type issues. My favorite one is this one called Weapons of Math Destruction, which is about the kind of dangers that models can cause. Okay, and I'll probably, if I have time, I'll go through some examples from that. Any questions? Anything people want to talk about at this point? It's always better to have a conversation than to just have me read slides to you. Any questions? Monk. So again, if we think about these kinds of things, again, what about economic disruption? I think that many people are right to fear that there's going to be a lot of economic disruption because of AI systems. As I recall, something like 2 or 3 million people in the United States are employed as taxi drivers, as truck drivers, as delivery people for Amazon and things like that. Obviously, self-driving cars threaten these kinds of work, okay? And so for many blue-collar jobs, the AI systems, there's a legitimate fear that they're going to cause a great deal of change, okay? Many of you may feel kind of smug about it. Well, I'm a computer scientist, or I'm an engineer or something like that. They're not going to replace me. But increasingly, a lot of white-collar jobs are kind of being threatened by AI machines. Certainly, for example, it seems to me like it's a bad time to become a pathologist, okay? A guy who looks at medical slides to decide whether you have cancer or not, okay? It may be a bad time to be a lawyer. A lot of what lawyers do, or were paid for, involves scanning through documents, learning to see if there is a cause, okay, for something. And now there are text analysis systems that do this kind of legal discovery very quick, and much less work for lawyers, okay? So basically, this is a concern that the world has and probably should have, okay? Now, the hope is that future jobs will involve working with AI, okay? And historically, whenever technology has destroyed jobs, there have always been more jobs that came out afterwards, okay? People worried, oh my God, when they started inventing mills for sewing, for weaving cloth, what's going to happen to the job for weavers, okay? Well, somehow the economy kept creating more and more jobs from this. I'd like to think that that's going to be the case, but it feels a little different than it did when it came to things that were not, let's say, necessarily mental work, but physical work. Any questions about that? Discussions, comments, feelings about the world? Okay. Okay, again, there are a lot of genuine concerns about privacy that people have, and some privacy concerns are just because it's different now than it used to be. Some things, it feels like that a lot of the in the U.S. Constitution they were which is the document that's 250 years old. Okay, there were concerns about making sure that people's house that there were rights to privacy in your house somehow, and you know somehow there's things that bother people. Recently there have become face identification systems. Again, there's cameras all over the place to monitor, make sure nothing bad happens, no crime occurs or anything like that. But more recently now, face identification systems mean that you can have a system that will identify every person that appears within, get the name of every person that appears in a camera anywhere in your building or anywhere that you're doing surveillance on. This bothers people, okay? And so there are definitely privacy concerns, and this has to be something you need to be aware of if you're building some kind of project. To what extent does it bother people? To what extent is it illegal? But also to what extent does it bother people? Europe has laws about dealing with private data that are much stronger than the ones in the United States. When they kicked into effect a couple of years ago, suddenly a lot of the U.S. companies started following these laws because they had subsidiaries in Europe, and so there are more effective regulations in some sense on internet data than there used to be. Okay, but that's probably a lot more due to Europe than because of the United States. Any questions? And like I say, there's not just concerns about whether there's a privacy issue about data. Do you have access to data that you shouldn't? But there's also questions of, are you doing things with the data that people don't like? And you can imagine models that even if you haven't released data on something that's very private, the model may try to infer it. There are models that claim to be able to look at people and tell whether or not they're gay. Okay, even if they haven't announced it, may not have announced it, but somehow the computer may still have an opinion about these kind of things. And these are the kind of things people get upset about. Any questions or discussion? Boom. There are these, as far as these bias concerns, okay, there are all kinds of cases where kind of engineers may not probably don't want to build systems that kind of have biases. But if you're doing machine learning on a data set, you're going to learn what that data set is, whether it makes sense or not. So one famous example of this was Amazon's resume screener. Amazon gets millions of resumes, every year for people who want to work there. Amazon, being Amazon, doesn't want to pay somebody to read every resume. Is there a way that they can look at a resume and decide whether this is a good candidate or a not good candidate, and throw away the ones that are not good candidates? Well, they tried to build such a thing. And what did they do to train it? They said, wait a second, we have records of all the people we hired at Amazon. And we have the resumes of all the people we didn't hire. Why don't we train something that looks at the words in the document and say which ones are most strongly associated with the ones that we hired, and which ones are strongly, are more strongly associated with the ones that we hired than the ones we didn't hire. And when they did this kind of analysis, what they found was, what was the single strongest word to make you get a job at Amazon? According to that model, it was whether or not you played lacrosse. Okay, that for some reason, among the test resumes they had, a bunch of them played this particular sport. They meant they were male. Okay, that was one of the things that it meant. Okay, and suddenly their Amazon would be looking for lacrosse players. Okay, instead of all of basically, because most of the people who had gotten jobs at Amazon were male, it learned to like men more than women. Okay, and that's the kind of thing that is a hard thing to do. It's hard to build classifiers that are accurate for minority classes. It learns to like the bigger classes that it had been given. Okay, and if these models are opaque, meaning they don't explain what they're doing, and that's a sign of trouble. And if everybody, there's kind of a separate phenomena. If everybody started doing the same thing, you'd have a world where employment at all these companies depended upon whether your resume passed this model. And this has the danger of being a very unfair thing. If I wrote a resume with the wrong word in it, I would be screened out of every company's jobs before they actually got a chance to actually read it. So these are the kind of things that people worry about with these kind of services. Any questions about bias or implications of bias? Any comments, anything like that?
Oh, yeah, I have a question.
Yeah.
Do you think it's possible for us to be able to build a model or a machine learning algorithm or something that can actually be more fair than people?
Well, okay, so that is a fair question. I think in general, people are biased. Okay, I like to think I'm a good person, but I have no doubt that I have certain biases and preconceptions of how the world works that are not necessarily completely justified. One of the good thing about AI systems is that presumably they are easier to evaluate for bias than individuals. Okay, I have hired in my life, if you think of it as graduate students, how many graduate students have I taken on? I have taken on, probably 30 PhD students and maybe, 150 master's students over my life or something like that. That's probably not enough to figure out if my algorithm is biased. On the other hand, if I am Amazon and have resumes that are screening 1 million people, it seems reasonable to say, gee, you seem to like women. You approved 13% of the women when 32% of the applicants were women. Okay, I think it's easier to evaluate bias in it's easier to evaluate bias in these AI systems. Okay, and there are. So anyway, I may have wandered, I may have rambled a little bit, but I think that it's possible to build. It's certainly easier to tell if systems are biased than if people are biased. That much I believe. Any questions? There are ways that people have done studies to show whether people are biased. One of the examples of this had to do with hiring musicians for an orchestra. Let's say you're an orchestra and you want to hire somebody to play the cello for you. How do you decide if somebody is a good cello player? Historically, they had the hiring committee stand there. They brought the person in, they played the cello, and everybody gave them a score. Very few women passed the cello test under this way. Then some of the orchestra said, well, why don't we let the person play behind the screen so the committee can't see who the person is. Just have them play the cello behind the screen. And when they did it, the committee started hiring a lot more women than they did before. So that was an example of where there are biases that people have. People certainly have biases. The trick is to make sure that your machine learning systems try not to pick up on them. Any questions or comments or discussion? No. And finally, like I said, there's people who are worried about, you know, what you call it, our machine's going to take over the world. If you want to read and get a little bit scared about machines taking over the world, this is a very good book. This book, Superintelligence, is written by a philosopher, Nick Bostrom at Oxford, I believe, who, you know, has intelligent things to say about about machines getting smarter and will we be able to control them? And I think that's an interesting thing. In the short term, there's probably a problem. Rather than the machines taking over from us, there's probably a bigger problem about whether we trust our machines more than we should. There is a kind of an ethical question. Should you have weapons have algorithms in them to decide when to kill people? Okay, you could imagine a world where a self-defense system, you might want to, you know, turn over the decision of there's a bad guy coming to attack us, kill them, over to an algorithm instead of to a person who's controlling the weapon. Is that a good thing or a bad thing? Okay, and this is a somewhat hard question. Obviously, bad things can happen if there are bugs in the system once you give the machine weapons. Okay, if any of you ever saw the movie Dr. Strangelove, that's sort of an example of what bad things that can happen when you know, you give the machine control of weapons. You know, but there's other questions. When is it that you know, self-driving cars are safe enough to drive? This is a decision people are going to have to make. You know, legislators and things like that. And it's important that kind of people understand the strengths and limitations of testing, how models can go wrong in order to make intelligent decisions about that kind of thing. Any questions? One thing that is an interesting, I will say, ethical thing is to make sure that what you call it, that mistakes are build systems so mistakes are correctable. If you have a resume screening program, that all you do is you submit resumes and the machine says sorry, thank you for applying. You know, it's hard to know who to complain to if the resume system is not giving you a fair chance. Okay, you know, a lot of things kind of, you know, if people are not in the loop, there tend to be problems with that. Any questions? Okay, any of these kinds of issues? So this book that I was kind of recommending, The Weapons of Math Destruction, this was written by a, you know, a data scientist / modeler, so someone like us. She's like us, okay. But she writes about what are some of the dangers that happen when you start trading, you know, as far as things like inequality, when you start building models to make decisions that govern people's lives. There's one level, you work for Google. If the decision you're making is whether to show me an ad or not, maybe that's not such a big deal. But in society, there are big decisions that sometimes these models are being made. And they end up having kind of feedback mechanisms in that once you make decisions based on them, it will keep leading to more decisions being made in this way. And this can create kind of problems. if we think about what makes a good model, we talked at one point about data proxies. A proxy, remember, was not data, or it was a measure or data that we had that we kind of think sort of correlates with what the thing that we want. But it may not be exactly the goal or measure exactly what we want. Sometimes people build models based on the data they have. That is not necessarily the data that you need to make the model. You want your models to be transparent. They've got to kind of explain why it's making its decisions. And the other thing that this book said that I found very interesting is that there's got to be a feedback mechanism so you can really judge whether the model is doing a good thing, okay? Making decisions, the right decisions. Just getting a good score on a evaluation set doesn't mean that it's, kind of necessarily, after you're using it in practice, making the decisions you want and you're going to learn from it. The example that she uses in this book that I think was very compelling has to do with rating how good teachers are. Okay? So, all of you guys have been in classes. All of you guys have had teachers. Some teachers have been good. Some teachers are bad. If you are a school or a school system, you want to fire the bad teachers and hire good teachers. How do you measure whether or not teachers are good or bad? Okay. Now, how does the university measure whether a teacher is good or bad? Does anybody have any ideas? What does the university do to measure whether teachers are good or bad? That if any of you ever gotten surveys, you get these surveys formed, there's teaching evaluations, right? That is one of the arguments that what they're trying to do is to figure out who's good, who's bad, and maybe try to improve the people that are there. But like in the United States, for things like, the kindergarten through 12th grade education, okay, school systems have to make decisions about which teachers to keep and which teachers to let go. And, there has been a lot of, let's say, struggle in recent years because these schools are trying to base it on data that they have. So what data do schools have about their students? Well, if the students have to take tests, standardized tests, things like the SATs or the GREs, or in general in school classes in the United States, in many states, they would make students take a standardized test every year. How well have you mastered the material for first grade, second grade, third grade, fourth grade? Okay. Some school systems latched onto the idea of saying, why don't we look at the test scores of all the students in somebody's class? Let's say Skeena is teaching a third grade class. Let's say we take a look at how the students did on their third grade class. Okay, we get their average score. If Skeena's average is less than the average of all the other third grade classes, that would be an argument that Skeena's a bad teacher and we should fire her. That's a good example of using available data. Are the test scores the students achieve a good measure, though, of how good the teacher is? Is it a proxy, or is it a real measure of how good the teacher is? Is there any confound you can imagine if I got graded by what the test scores of people in my class were? Is there some kind of a confound where maybe you're going to be grading me in ways that don't necessarily reflect how good a teacher I am?
You might be only teaching to the test material, or you could be teaching them to cheat on the tests.
So one possibility is that if I am teaching the students only the test material and not stuff that is necessarily I think is important or interesting for their societal thing, you would end up getting teachers that will teach to the test. That would be one thing. And if I was a creative and exciting and motivating teacher, I would get slaughtered by these reviews. That would be one of the things. Another possibility you say is to cheat. How can I cheat in this kind of a world? Maybe I make sure that all the bad students in my class flunk out before they actually take the test at the end of the year. Does everybody see that I now, as a teacher, instead of trying to work with a student who's at the bottom, my goal should be to try to get that student kicked out of class for fighting or drugs or something like that, okay? Because that way my average will be higher, okay? Does everybody see that there's a relevant, that there's a question between the test scores tell you something about how good the students are in your class. They may or may not tell you about how much the value you add is. You want your models to be transparent, okay? There turn out to be is it transparent to hire and fire you based on what your students' test scores are? I guess the system's kind of transparent. One way to tell that it's transparent is that you can tell that there's statistical significant problems. If I am teaching a class of 20 students, how reliable is the average score going to be from these 20 students? It could be they had a bad day. It could be there's statistical issues, and the models these school systems used often did not satisfy the statistical significance tests. And finally, there isn't really a feedback mechanism. Suppose I have a school system and I fire the 10% lowest scoring teachers every year. I will have succeeded in firing the teachers that had bad test scores. Is there any way I know whether the teachers I fired were really the bad ones or not? Okay? There's not really a direct feedback mechanism. All of these teachers are fired, they're gone. I, the school system, don't know if they were good. They may have gotten hired by another school system and done great, okay? In an ideal world, when you're implementing this kind of thing, you have some kind of a feedback mechanism so we can learn how valuable these are. Any questions about that? Okay, this is where I'm going to end it. I encourage you to read Weapons of Math Destruction. I really encourage you to read my textbook to prepare for the final. I will thank you for your attention this semester. Obviously, this has been a weird semester because of the Zoom teaching and stuff like that. This has been suboptimal for all, but we did what we could try to do. Any questions about the exam or the material or anything else? If not, I look forward to seeing your term papers on Sunday. And I look forward to that eventually seeing you on the 17th for the exam. Any questions? Okay, thanks a lot.
Professor, do we have office hours today?
I will have office hours today. So if you want to come by, I'm now going to go to office hours. Okay.
For the exam, should we prepare from every chapter in the book or just certain chapters?
I am going to give you one. My plan is, I believe there are 12 chapters in the book. Am I right? Is it 12 or is it 14? What is it? Forgot about that. Okay. I'm going to tell you that my plan is that if there are n chapters in the book, 1/n of the problems will be on each chapter. There are 12 chapters in the book. My hope is that I will give you 12 different problems, each of which is kind of based on the material in one of the chapters. Any questions? So no chapter is more important than any other chapter. Any other questions?
Is it possible that a question might appear on the test that wasn't covered in a lecture but was covered in the textbook?
The answer is it is possible. Okay, so I do encourage you to read the book. I don't intend to make it a gotcha thing, but I am not going to. But I as far so my hope is that that you will read the book. Okay, my book lectures have generally covered what's in the book, but I encourage you to read through the book. Okay, without me trying to make this a gotcha thing. Any questions? Okay. If not, take care, good luck, and